So today we're working on this 97 Lexus ES300, and we're getting some transmission shift solenoid codes. So one is P0773, there's P0758, which just came up. There's P0758. And then this one I think is a memory. I think this one's a memory. Alright, so anyway, that's what we're going to work on today.
So we did some research. We found out that Shift Solenoid E, when you have a P0773 code, is actually the Shift Solenoid SL, which is located in the valve body in the transmission. So here's a little diagram of, there's Shift Solenoid SL, and then it's the pink and blue wire going from the computer to the Shift Solenoid SL. So to check the solenoid, and we're going to actually check it from the connector where it connects to the transmission to ground. So what you do is you're going to measure the resistance between the terminal, and we can measure it from the terminal where it plugs in at the transmission, or it shouldn't be a lot of difference. This is the plug inside of the transmission here to ground, and then you're allowed, the resistance measurement is 11 to 15 ohms. That's what you're supposed to be getting. Now electrically, okay, so here's another diagram of our shift solenoid. So the one we're concerned with right now is this one right here, this Shift Solenoid SL. You can see here it says pink and blue, and they're calling it SL. If you look at the letters here to the computer, this is SL. Okay, now we're also getting a 758 code which just came up, Shift Solenoid B. And but anyway, the way you're going to check this is it's grounded. So you got a one wire pin plug coming from the computer going to the solenoid. So what we're going to do is we're going to check the pin going into the transmission to ground, and we should get 11 to 15 ohms for that. Okay, and then we also got these dual solenoids in parallel. So we're going to check. And then this is the pink and blue wire here. P and L, that means pink and blue. And then these are the pair that we got two solenoids in parallel, and they're grounded also. So that's going to be the yellow wire, and it looks like the blue and black wire. And then you got another solenoid, and it's being grounded in the computer and powered by the computer. So that's the black and yellow and the white and blue wire. So what we're going to do at the connector, we're going to measure it at the transmission. I've been thinking that this latest code, because I had this plug off recently, and I think that when I took off the plug, when I put it back, I might have pushed one of these pins. I think that's going to be my problem. But at the time, these things were reading good, except for this one. This was definitely had a bad reading, so we're going to check that right now. Okay, so you have to remove the left front tire, and there's a little access panel here that you should take off in order to get, so you can see that electrical plug for the transmission solenoid. So we took that off. So here, this is our connector right here. This one here, kind of here on the top, that's going to be our connector that has all of our solenoid inputs and outputs. We're going to check that first. Okay, so now we're going to measure through these wires for the resistance. Okay, so the one I'm kind of concerned about right now is this. I checked this one earlier, and this is definitely bad. We're going to check it again anyway. So now we're going to check this, between the black and yellow and the white and blue wire going to the solenoid inside the transmission. So we're going to check for continuity through that solenoid. So the black and yellow, here's the connector. So this is the black and yellow wire is this one here, and then this is the blue and yellow. So that will correspond to the connector is down there. See the connector? That's going to be the connector. So we're going to go for those two pins which correspond to those wires at the connector, which are going to be the top two, those top two terminals, the top two terminals here. Now on the top of the connector and the top on this end, we're going to check the continuity between those two right now. We got the meter connected to our that's going to be our blue, or it's one or the other. That's going to be the blue, the white, the blue, the black and yellow wire terminal is there, and then we're going to check, and then we're going to put the other meter probe right across from that. We should get continuity. So let's go ahead and check. So we got our meter probe there on our other terminal for that solenoid, and then we're getting 5.9 ohms, which I'm sure is fine. Okay, let's check the other ones. Okay, so now we're going to check our SL solenoid. So we're going to go from the pink and blue wire, which is the center terminal on that, which I got it connected to right now, to ground. And you should be getting 11 through 15 ohms. So we're going to go to our ground connection here in the battery. And as you can see, it's wide open. Let's try a higher, see if we get anything. There's still nothing there. Okay, now we're at 2,000 ohms. So that's not going to be any good. We can make sure our meter is good. So our meter is good. Make sure our leads out. Okay, so that's the meter is good, but so that we got a bad solenoid definitely. Okay, so now we're going to check these solenoids, which are in parallel.
So one is the violet wire.
One is the, looks like the, okay, one is the yellow, and the other one is the blue and black wire to ground. So we're going to check those now. So here's the yellow wire, and the black wire on our connector is or one is, maybe it's violet. Okay, that's violet. Okay, so the violet wire is going to be this one, and then that's our blue and black. So we're going to check each of those to ground to see if we got continuity through those solenoids. Okay, so first we're going to check our violet wire to ground. So we're on our violet terminal down there at the plug, and we're going to go to ground and see what we get. And we're getting 15.
I think you're allowed 11 through 15, so that's going to be okay.
Let's check that last one. So now we're on our blue and our black terminal on the connector. So let's check this. So you go to ground. And you're getting, oh hey, how you doing?
Very good.
And you're getting 50, so that's within tolerance also. So that's going to be, so our only problem is really going to be that one, this pink and blue, which you know was bad to begin with. So we're going to go ahead and replace that solenoid. So the shift solenoids are in the valve bodies, and the valve body is in the. You got to take off the transpan to get access to the valve body. So we're going to do that right now. Got to take it off evenly from the outside, and if you can, it's the best way to do it. Okay, so here is our valve body. So I already took off the filter, so now we're just going to all the solenoids are above this, so we got to remove this. So it's not a big deal. You've just got to watch, be careful, don't drop any. You want to keep this thing level as you lower it, because if there's any small parts on the top and they fall out, that's not going to be good. So, and then it's got these tubes. You want to make sure, mark where all these tubes go. They're pretty much pre-bent, and they're only going to go in one place. You can maybe get some tape and put it on there so you know which one goes where. There's one over here also, and they're all clamped with these clamps. Our solenoid that we need to find out about is this yellow wire is going to this yellow wire, and you can see the wire is going above the valve body up here. So we need it. That's where we got to take it out. They're all up here above it. So we're going to do that right now. So when you remove these, you remove the valve body, just remove the larger bolts. Okay, you've got 12 millimeter. This looks like it's a 12, or maybe it's, well, you don't want to, don't remove the smaller bolts because they're holding this plate onto the valve body. Don't remove this. Just remove the larger bolts. Here's one here, and then these here. This is going to come off also, but just do the larger bolts. You don't need to take off all these little bolts, just the big ones, the larger ones, and then that's going to cause this whole unit to lower, come down. Okay. So when you do this, if you have any questions, it's a good idea to have your camera ready and just take a lot of pictures of it before you take it apart, especially these tubes. You want to make sure that you get the right tube in the right place. So take pictures, put tags on it, whatever you got to do. You know, I don't want to mix anything up. So to take out these tubes, all you do is you can just, you know, if you take out, this had a hold-on bracket, right, a bolt for a hold-on bracket right here. So now that's out. So now this thing should just come out, and it's already loose. So just kind of, that's going to come out now. So just kind of slowly work it out of there. Don't bend anything. Let's slowly kind of make it come out here. Okay, there's one. Two. And also, when you take this apart, if you keep the bolts through the bracket or whatever that held it on, it's really going to help you keep track of where everything went. You don't want to get anything mixed up. So if you keep the bolts in the holes of the part that it held on, that's really going to help you a lot. Okay, so we got all the tubes out. Now we're going to take out, this unit also has to come out. This is your shift lever, your shift pattern valve from your shifter. And so this unit's got to come out. Just take pictures of everything before you take anything apart so you know where it goes, you know, when it comes back, when you put it back together. Okay, so we're about ready to lower this. So you just want to remove these larger bolts. These are like 10 millimeter bolts, not these 8 millimeter. Just the larger bolts is what needs to be taken out. Don't take out all these bolts because you're going to screw some up. See, there's several of them. There's one here, here's one, but just all these big 10 millimeter needs to come out, and this will lower. Okay, we're going to do that right now. Okay, so one word of warning when you do this is there's a shift pattern cable here, which needs to be disconnected, and that's it goes right here. So, and it's not a big deal, but you're going to be lowering this thing against that. So you've got to make sure that you disconnect it. It's just the cable just goes through here, and so make sure you disconnect it, or it's going to be hanging there on you. There it goes, right? It goes to there. So make sure that thing is good, is removed before you lower this, or you're going to be you know, good thing I was able to grab a pair of needle nose pliers and get it off before I damage something. Okay, so just make sure you move this cable before you take off the bolts. Okay, so here's our bad shift solenoid right here. So let's just verify our reading here. Connector. So we're going to go here to the case, the ground, You should get 16 ohms, and we're getting it's an open solenoid. It's wide open. Check our meter works. Our meter works. Okay, so here's our bad solenoid reading again. Let's check our meter. Meter's good. We got an open solenoid. So there's a new solenoid right here. Here's a new solenoid reading here. And there's a good solenoid, about 13.7 ohms. Alright, so we're going to now install the solenoid and fix the car. Okay, so the first thing we're going to do, obviously, is put the solenoid back. So whenever you reassemble transmission parts or anything in the transmission, you want to make sure you got transmission fluid coated on the parts or the seals so everything slides together nice and easily. So we're going to get some fluid right here. Put it on our seals. You don't want anything binding and chafing. And the solenoid's going to go right into here. Put some fluid in there if you want. It'd be nice. Bolt in your bolt. All right. Okay, so we had a little bit of a delay because in removing the valve body, I had damaged these upper valve body gaskets. This one and this one. Here, I'll show you what happened. So here are the old gaskets, and I had broken the corner of this one here, and then this one here. The edge I broke off it because they get really brittle. So I had to get these gaskets, and it made another delay. And it's you got to be really careful when you take that valve body apart, because you can get in, if you don't do it right. You know, I have the directions right here. You have to really follow this procedure, because if you don't do it correctly, it's got check balls in it and all this little parts. So you just got to be careful. You know, use the right procedure. You got to hold the valve body plate on. It's a long story, but anyway, if you do it, just make sure that you know, if you don't really have a lot of experience as a mechanic, it's probably not a good idea. If you don't have the information you need, you can probably get in a lot of trouble. You might have to take it to a shop then. But anyway, so that was replaced. Okay, so here's our valve body again. So we're going to do some last minute checks before we install this to make sure that our solenoids are actually okay and nothing kind of broke in the interim. Okay, so let's check our solenoids one last time before we install this and make sure everything is good. So here's the solenoid that we just replaced. So we got our meter hooked up, and we're getting 13.2 ohms. So we need 11 to 16. So that one's good. So we're gonna, okay, so we're also gonna check our shift solenoids 1 and 2, which are these two right here, and they need to be 11 to 15 ohms. So let's do one at a time. So let's check. These things are in parallel here. They go through this connector and they go there. So let's check one here. This is going to be, okay, so it's 14.1 ohms, so that's good. That's the one with the red wire, which is this here. Let's check the other one. These things are actually in parallel, and one will, if one fails, the other one backs it up. But if either one fails, you'll get a code. So for some reason it got a code. And then there's the other one, 14.0. So the resistance is fine of the solenoid. So either the connection between the connector where it connects at the transmission has got a bad connection at that point, which I think that's going to be the problem. I don't think it's a solenoid. Last but not least, we're going to check our shift solenoid SLN. Now this has got an input. The ECM is controlling the power and ground to this. And the resistance of this one needs to be, I think, 5.1 to 5.5 ohms. So let's check this real quick. So I got one terminal there connected. I'm getting about 5.6. That's like marginal. Jeez. Okay, so our meter's reading 0.2 ohms, so we can subtract 0.2 from whatever reading we're getting. So we're at 5.6, 5 point. So you're within reason. If you subtract 0.2 from that, you'll get 5.3. So we're all right. Okay, so now when you put this in, the key thing is you don't want to get these wires pitched, and you've got to also deal with this pattern cable for the, this is coming from the throttle. This cable right here. This is coming from the throttle, and then you don't want to get these pinched either. And then, you know, other than that, you'll be good. Just make sure your gasket, don't damage the gasket when you put it back, and you'll be cool. So let's go ahead and put it in. Okay, so when you put in these tubes, and you got to put them in order, obviously. So this one is going to go over here, and it goes in a hole right in there. So you make sure you put transmission fluid on the end so it slips in nice and easy. I got our transmission fluid right here. So we're going to go between here and here. And you can get a little hammer if you want. Plastic mallet would be good, but if you have a little hammer, I think you'll be fine. And just tap it in. You don't damage any wires. It's all the way seated. Okay, so here's our assembled valve body. We got all of our tubes in. This plate here kind of holds in the tubes. It's bolted over. It's like a hold down plate. And then this one here has got a little bracket which holds this one on. And then there's a bracket here also for that one. And then I think that there's another one here underneath the filter, and it's got a little bracket that holds it in too. And then your plugs are these little. Make sure that nothing gets pinched. So these wires should have got a loom down through here loosely, and they were okay. And then they're all connected. So now we're just going to check our resistance of our solenoids through the connector before we put it all back together again. Connect it and fire it up. Okay, so the first thing we're going to check is our pink and blue wire. This is our main issue right here, our only problem. You know, it could be our only issue. Maybe there was something else that cropped up after the last time I worked on this. So this needs to be about 11 through 16 ohms. So let's check that. Let's check this. And we're getting 13.6, so that's going to be good. All right. Okay, so now we're going to check our blue and black and our violet wires, and this is solenoids A and 1 and 2. Okay, so now we're going to check our solenoids 1 and 2 for this other code that cropped up. So we're going to check, and these are the same plug. So we're going to check it at this point to ground, and then we're going to plug it in and then check it through the computer and through the connection, which will verify the connection is good. Okay, so let's check those now: the violet and the blue and black. So this is going to be the violet. Solenoid 1, and that's with intolerance. That's good. And this is solenoid 2, the blue and the black, and that's good too. So now we're going to check our SLN solenoid. So that's going to be the black and yellow to the white and blue wire at the plugs, and we should get about 5.1. We did this before. I think it was 5.1 to 5.5 ohms. And add 0.2 ohms for the meter. So we're getting 5.6. 5.6. So you can add, you're at 5.4 for that. So that's going to be all right. All right, those are good. Okay, now we're going to check it through the connector. So the way you do that, you got to get a T-pin. And now you guys. Okay, now we're going to measure through the connector. So now I've installed a T-pin. Now we can see this T-pin down here, but this is the T-pin. That shiny anyway, that's the T-pin. Okay, so now we got plugged in the pink and blue wire, and we're going to check that circuit again. And it's also going to reach the computer, so the resistance is going to be lower. Okay, so now we're reading through the circuit, through the T-pin, through the connector into the circuit in the transmission, and we're getting 13.2 ohms. So that's a little less. So that's, I think, our connection to the computer is still good. Okay, and through the connector is good. Okay, so I'm satisfied with that. Okay, now we're going to do. Okay, now we're going through the blue and black wire, and we got 13.8 ohms. And I'm thinking that that's good. It's definitely reading through the solenoid because it's 13.8 ohms, so that's going to be good. Okay, let's go to the pink violet wire, which is at solenoid 2. And the violet wire is also reading 13.8 ohms at solenoid 1. Okay, good. Now we're going to do our SLN solenoid, and that'll be done. So our other meter died in the middle of doing our verification. So now we're measuring through the SLN solenoid, and then here are the connections again. Was the white and blue, and then the black and yellow wire. So we're just reading just through the solenoid only. It's not making a lot of difference because that's a really high resistance circuit in the computer. So anyway, so that's going to be good. All right, now we're going to put fluid in it and get ready to put it all back together and fire it up. And another thing I wanted to add is the shifting is much more. It's smoother. It's you don't feel as much of a downshift after since this has been repaired. You don't feel this downshift coming to a stoplight, and the shifts are more. It's not as abrupt, so you'll really notice a difference. You know, the gas mileage also should be better because now the lockup solenoid is working, so the engine isn't revving as high as it did before because the lockup solenoid keeps the torque converter lockup solenoid keeps the converter, that slipping caused by the torque converter is eliminated when the lockup solenoid energizes. It kind of disengages. It's kind of like a mechanical clutch in a regular transmission, so the engine won't rev as much at cruise speed, so it should also help our gas mileage a little bit. Anyway, so another thing I wanted to mention is some of those other terminal connections that went to the other solenoids at the plug at the transmission, and then you've got a couple of connectors inside of the by the valve body. You'll see the connector for you got a shift 1, a shift 2 solenoid, and then you got this other solenoid, which is I think it's like it's another solenoid in there. The connections will tend to get loose just from years of use, and because it's actually the connectors in the valve body are submerged in transmission fluid. So through heat and use, the actual I could actually grab each wire at either end of the connector and pull them, and it was loose. So, and I had a little bit of a question regarding maybe some of those other solenoids. We were getting another code, but it may or may not have been related. But you just want to make sure that it's fixed. So, with that in mind, you can tighten the female terminal in the connector, in each of those connectors, by just bending the tabs. I wish but if it's a spade terminal, it's got like two little, you know, the female end. You can kind of get a small screwdriver and bend those down a little bit, and then when you put the connector together, it'll be a tighter connection. So then if there's any kind of intermittent problem there, you've eliminated it being because of a bad connection at that point. And then also at the plug where it goes into the transmission, the same thing, you've got where the female terminals are. Sometimes just I notice that on Lexus, after they get kind of old, I guess the female connectors will just kind of get bigger, you know, not necessarily because of use, just maybe because of current going through it. I don't know what it is, but it's a good idea to just if you can bend the female side of that connector to make it a little tighter, so when the other pin goes in, it's tight, and it'll be a better connection then, and then you'll eliminate any bad possible connections at those points. So just another little thing that I did on this one, you know, to eliminate any possibilities that we had any kind of bad connection problems. That's all been eliminated. So anyway, the car is fixed, and we're going to take the smog right now. Okay, thank you again. Okay, so we just fired up the car, and as you see now, we have no diagnostic trouble codes. All the monitors are complete, so we should be able to. It's just giving us here an update. Was this the times? So right now we should be good for smog. So we're getting ready to take the vehicle back over to smog. So this is Steve's story again at Car Inspectors. Please subscribe to my channel. I hope you learned something today in this scenario of repairing transmission shift solenoids. Thank you very much.